Hello, welcome to Anson Griffin's occasional series in Matlab. Today we're looking at something relatively tight, I won't say trivial, but minor, fairly detailed. So we're looking at these maxim functions for grayscale images. So first up is IMHmax. So we've created an array, zeros, and then we've put in threes, rows 2 to 4, columns 2 to 4, rows 6 to 8, columns 6 to 8. And then we are calling IMHmax, image H maximum. There's the result. So what we're doing is we're suppressing it, all maxima in the intensity region whose height is less than H. So there is a maximum there and we suppress it. Why do we suppress it? Because the height above it is less than H, the height is less than 4. So that's gone there, the 3's are gone, and then H is greater than 8, yeah, but we suppress it by 4, so that gives us 4 there. Okay. IMHmin. We've created an array again. We've created two valleys in rows 2 to 4, columns 2 to 4, rows 6 to 8, columns 6 to 8, and we're calling the function IMHmin here, and again 4 is there, so we have the A repeated twice, and there's IMHmin. So here the depth here is 3, but we said 4 was the threshold, so we suppressed that minimum. The depth here is 8, so we keep the minimum, but we raise the floor by 4. 2 and 4 is 6. Okay, regional min. Create an array, basically 10 by 10, created two valleys, rows 2 to 4, columns 2 to 4 with 2, rows 6 to 8, columns 6 to 8 with 7, call regional min, and we found here its neighbours are higher than the 2's, so that therefore the 2's all become 1, and the 7's are surrounded by 10, so they become 1. So B there is a logical. IMimpose min, a little hard, or harder than the previous example, so I know when I did this in class it took a few minutes to explain. So we read in the image and we showed the original image, so I have to jump up and down here a little bit. There's the original image. Grand. Here we create a logical image called marker, and it's the same size as the original image, and in rows 65 to 70, column 65 to 70, we make it true. So I'm going to show that. There it is. So it's all black because it's false, and then row 65 to 70, column 65 to 70 is true, so we see that as white. Now next thing is we let J equal mass, so J has the same values as the original image, so that line I have shown it underneath, but it's pointless, and then J 65 to 70, 65 to 70 is white. So there it is, we've sort of stamped that. And now on this, so this line, now J is only to help the student understand what's going in. IMimpose min mask marker. So remember, mask is the original image, marker 65 to 70, 65 to 70. So wherever that white spot is, we're going to impose the minimum at that spot. So we're going to impose 0 there. And just in case, K there, so K is the resultant of the impose min. And I said what are the values of 65 to 70, 65 to 70, and they're all 0, as you would imagine, because we're making that the minimum. There's the original image, there's the mask imposed, and there's IMimpose min. So more about there, I can just about see it on my computer screen. That bit there is pure black, that is the lowest. Now, if that's the minimum and there were other minimum, the other minimum have to be elevated, because we only want there down here to be the only minimum, to be the only black. So the others have to the other minimum have to be elevated, and you have to elevate everything by the same amount. So that's why this image here, the impose min image here, is lighter or brighter, whatever word you want to use, than the original image here. Okay. Next one, regional max. So we create an image. This isn't perfect, unfortunately. So we created this array A, and then I call regional max. So unfortunately now I should have just typed A here. So, but I have typed it down here when I'm using extended max. So I'll have to be jumping up down a little bit. That's not A. That's the initial A, but that's A. And again, just the way this fell, it fell across 2 pages. So not perfect. Anyway. So we have 21s, and then we have a 44, a 45, a 46. Here we have 22s, and here we have 33s. Okay. So I called IM regional max. There we are. So the 22s are higher than the surrounds of 21. The 33s are higher than the surrounds, so that's okay. And 46, this is because the way it's 46 corresponds to that one there, so that's higher than its surrounds. Okay, so now 45 doesn't show up. You see there, 45 doesn't show up. Why? Because 45 isn't higher than 46. Now it may be higher than 44, but it ain't higher than 46, so therefore it is not a regional max. And again, 44 is bigger than 21, but 44 ain't bigger than 25, so therefore it's not a regional max. So the regional max, we only get the one there for the 46. Now, the one that caused all the trouble in class was extended max. So the threshold, I made up a good example, I hope, to explain this, and the threshold there is 24. Okay, so that's the original image, and again this is a little disconcerting for the viewer because the way A has fallen across 2 pages here. And C is the result of IM extended max. Now 24 is the threshold. So the 22 is bigger than 21, but it's not bigger than 20 by 24. So that goes. The 33s down here, they're bigger than 21. So that goes. Okay. And now the problem is to explain the 46. The 46 corresponds to, I have to get this exactly right now. This one here corresponds to this 46 here. So 46 is bigger than its surrounds, or other than the connected one. Now this is the problem, other than the connected one, by 24 or more. So that 46 becomes a 1. The 45 is bigger than its surrounds. Where am I? There's the 45, where I am there. It's bigger than its surrounds by 24 or more, except here. And that one there corresponds to 23. So 45 is bigger than its surrounds by 24 or more. So all the other ones go, but this one, the 23, there's only a difference of 22, so that's kept. Okay, we're not saying 23 is big. We're not saying 23 is bigger than the 21s, but we're just saying the 45 is bigger than 23 but less by 24, so we keep that. Now the 44 is again not bigger than 21 by a distance of 24, but 44 is connected to 45. The 45 is bigger than the 21, so that's the 24 difference. And since the 45 is connected to the 44, 45 is bigger than 44, but by less than 1, so we keep the 44. I hope that explains. I Mightn't have done my very best, but I think it's okay. Okay, so thanks very much.